All right, let's jump right in. We're going to talk about something that's becoming a huge part of all of our lives, those smart medical devices. And, more importantly, a really groundbreaking new way to make sure they're safe and that our data stays private.
Yeah, that's a pretty scary thought, right? But it's not just some far-off sci-fi idea. It gets to the very core of a massive challenge we're facing right now. All this amazing medical tech is getting smarter, it's all connected, so how in the world do we keep it safe from bad actors? So, all this tech lives in what's called the Internet of Medical Things, or IoMT for short. And it's exactly what it sounds like. Just think of this giant web of connected devices, everything from wearables to implants, that are all talking to each other, monitoring our health, and sending super sensitive data back and forth all in real time. And look, this isn't some futuristic concept. This stuff is here, right now. You've got your smartwatches, ECG patches, insulin pumps, even pacemakers. These are all real-world examples of IoMT devices that people rely on every single day.
But here's the catch, right? All that connectivity, which is what makes these devices so powerful, also makes them vulnerable. We're talking about a huge target for malware, and an attack on one of these devices, it's not like getting your email hacked. This could be a literal life-or-death situation, threatening not just one person, but the whole healthcare system.
Okay, so we know there's a problem. So what's the solution? Well, people came up with a pretty clever idea to tackle this, but as you'll see, it wasn't quite the perfect fix.
This big idea is called federated learning, and honestly, it's a brilliant concept. The whole point is to train a big, smart AI model to do things like spot malware, but, and this is the key part, without ever needing to send your personal, raw health data to some central server. All the learning happens right there on your device, so your privacy is, in theory, protected.
But it's not a silver bullet. The traditional way of doing federated learning has some serious flaws. For one, it's slow, like really slow to learn. It also creates a ton of communication traffic between devices, which just burns through battery and bandwidth. On top of that, it can be unfair. Some devices' data gets treated as more important than others. And maybe worst of all, there are still security holes.
Okay, so that brings us to the hero of our story. To fix all those problems, researchers came up with a brand new framework. It's called FedGCL. So, how does FedGCL pull this off? Well, it's basically a 4-step upgrade to the whole system. First, to tackle that slow learning problem, it learns smarter. It uses a technique called contrastive graph learning to spot really complex malware patterns way faster. Second, for the fairness issue, it uses something called a Jane index to make sure every device gets a fair say based on how good its data is. Third, to cut down on all that chatter, it syncs way more efficiently with an adaptive scheduler. It saves resources, speeds things up. And finally, to plug those security holes, it locks everything down completely. We're talking homomorphic encryption inside a trusted execution environment, which means the data stays private even while it's being processed. All right, so that all sounds fantastic on paper, but does it actually work? Let's get to the good part, the results. Let's see how FedGCL really performs when put to the test.
Let's just start with the big one, the headline number. FedGCL hit a peak malware detection accuracy of 98.9%. Wow, that's about as close to perfect as you can get.
But it's not just about accuracy, it's about speed. Look at this. To get to 96% accuracy the old way, FedAvage, it took 6 rounds. FedGCL, it did it in just 3. 3! That means it learns twice as fast. It literally cuts the training time in half.
And it's not just beating the old standard. When you line it up against other, newer frameworks, it's not even a contest. Look across the board here. Higher accuracy, better F1 score, and it gets there faster than anything else. It's a clean sweep.
Now, you're probably thinking, okay, what's the catch? This must be a huge drain on the device's battery, right? Well, that's the most amazing part. All of this huge jump in performance and security, it only adds about 10% more computational overhead. That is an unbelievable trade-off. Okay, so let's take a step back from the numbers for a second. What does all this actually mean for us, for the future of healthcare?
Well, why does any of this matter? It's simple, really. It means better safety for patients, period. It means our most sensitive health data is actually kept private. It helps build a healthcare system that's faster, fairer, and just plain works better for everyone. And at the end of the day, it's all about trust. This is the kind of breakthrough that gives us the confidence to really lean into the amazing potential of connected medicine.
So what this all proves is that we don't have to choose between smart and secure. We can have both. We can have a system that's powerful and also protects our privacy. And that leaves me with one final, pretty exciting question to think about. If we can build guardians for our data that are this good, what's next? What kind of incredible, truly personalized medicine is now possible?